All right, welcome back, everyone. We are now going to progress and look at geometric series. So when we see a formula like this, you look at it and you say, wow, I could really imagine myself very easily forgetting that, so I better write it down somewhere, or I should have some strategy to remember it, or maybe I should learn where the formula comes from, which I can learn from my textbook or from YouTube. Or you could come into the meet and ask Mr. Jennings and challenge me to say, "Hey, Mr. Jennings, can you derive these formulas yourself?" And yeah, I can. I couldn't do it I didn't invent this stuff, but I can. I know the methods, so I know how to build these formulas. So anyway, and this is one of the most beautiful ones, I think, in terms of its derivation. So if you only do one extra thing today, figure out how this formula came about. Read that in your textbook. All right. So let's go ahead and apply this formula to various problems. So here is a geometric series. First, I want to be able to recognize, is this arithmetic or geometric? Grows by 3.
Mr. Jennings?
Yes.
You're not presenting.
Oh, very good. Thank you very much. We're all learning. I am learning. Okay, so let's take a look at this formula here. So here's our formula. This is one of the most beautiful formulas to see its derivation, but I recognize that everyone wants to get at it and get practicing. So I'm not going to do that in front of you, and I'm going to hurry up. So let's apply that formula here. We want to first make sure that this is indeed a geometric sequence, that this is a geometric sequence. Here it grows by 3, it grows by 6, it grows by 12. So I notice that it's definitely not an arithmetic sequence because it's not growing by the same amount every time. But if I look at the ratios, 6 divided by 3 is equal to 12 divided by 6 is equal to 24 divided by 12, and so on. So it's definitely a geometric sequence. Okay, so that's how we would prove that. And then we want to write down, well, what is the sum of the first n terms of a geometric sequence? And so let's take one more look at the formula. It is the first term multiplied by parenthesis 1 minus the ratio, the common ratio between the terms, raised to the power n, all divided by 1 minus the ratio. So let's take a look at how that's going to crack down in here. So I'm going to rewrite the formula. It's very good for your memory to do these things. A times 1 minus r to the n, all over 1 minus r. All right. So now for this sequence here, we know that the a is the first term, is 3, and the ratio r, oh, that's also 3. Okay, so that's going to be easy. We just substitute 3 in for all those spots. But then for n, we know we've been asked to find the sum of the first 12 in this sequence. Okay, so s at 12 is going to be equal to 3 multiplied by 1 minus 3 to the 12, all divided by 1 minus 3. Okay, so this here, I don't have my powers of 3 memorized to 12. So again, you're going to you use your knowledge of exponents and say that's 3 raised to the power 12. And that's equal to, oh, okay, there's a beautiful number. It's hiding a 144. So maybe that's, again, something that my predecessors did because they also love Fibonacci numbers. Okay, so here we go. We're going to have S12 is equal to 3 multiplied by 1 minus 531441.
When you come, we'll have to build something else. Do you think we can do that?
All over 1 minus 3. Okay, so we notice this is going to be a negative number, this is going to be a negative number, so the answer will be positive. And that shouldn't surprise out anyone because these are all going to be positive numbers. There's not going to be any negative numbers in the series. Okay, and so now this is something you would plug and chug on a calculator. I'm going to have a negative 2 on the bottom, and I'm going to take this number here, and I'm going to say 1 minus that number equals, well, there it is. As I mentioned, it's a negative number. We're going to multiply that by the first term, which was 3. and that equals that. And then we're going to divide it by 1 minus 3, which is minus 2. So divide by 2, negative that, equals, there we go.
Okay.
So that is apply the formula and plug and chug. It's kind of a dry topic, to be honest, because it's just I've just given you a formula and you just plug and chug it. But the way the formula arrives is so beautiful. So that's where the beauty is hidden. 797160.
I was just putting my puzzle back in the box, you know.
The only real trick here, once you're at this stage, is to make sure you do the bedmas correctly. Do the brackets first, and then multiply by 3, and then do this first, and then divide by that. You have to remember that it's as though there's brackets around that. You have to finish that operation. Call it minus 2 before you progress. Now, here is a word problem that shows you some of the applicability of geometric series in the world. So, if someone is earning a $35,000 salary in the first year of their career, but every year it grows by 3%, okay, how much do they earn in the first 25 years of their career? All right, so this is a practical question. We're going to see a lot more, even more practical questions tomorrow and Friday as well. So, and you're going to be using some in your assignment as well. So, if we wrote this series out, it would be the sequence out, it would be 35,000, 35K. Okay, I'm just going to write down 35K. It saves me writing down all these zeros. Plus 35K multiplied by 1.03. Okay, this will be the same number as this, but bigger by 3%. Okay, that's his second year's earning. His third year's earning is 35K multiplied by, well, it's the same amount that he earned this year, but also with another 3% raise. Okay, so there's a nicer way to write that down. It's 35K multiplied by 1.03 to the power 2. Sorry, people are comfortable with this K means 1,000. Sorry, 35,000 is 35,000. Okay, so it's not a variable that I have to solve for. Okay, so his money is growing by 3% each year, and we should probably write that down as increasing powers of 1.03 to the 2. Sorry, to the n minus 1. Okay, this is the first term. This is the second term. So this is 2 minus 1 is to the 1. This is the third term. So this is 3 minus 1. So this is to the 2. Okay, so that's the geometric sequence that's going to produce his total earnings in the first 25 years of his career. So let's just crank our formula and plug and chug. All right, so cranking the formula and plugging chugging looks like this. The sum of this series to the first 25 terms is going to be equal to, and we want to have a good estimate here as well. So 25 years, he's making 35,000, but his income is growing exponentially, and it's growing at a fair rate. So I would say maybe it's about like maybe about $1.5 million be my guess. And let's see how close I am. I didn't spend a lot of time on the mental math because I'm sensitive that everyone wants to get going and get practicing. So this is A multiplied by 1 minus R to the N, all divided by 1 minus R. Okay, that's our formula. And then I'm going to plug in 25 and A and R. So A is the first term, and it's 35,000.
How did you do that?
And then R is the ratio, and that's 1.03. Okay. This one is bigger by a factor 1.03. This one is bigger by a factor 1.03 from this one by that ratio. Okay. And then our N is 25. So let's go ahead and we'll do this. Okay. So when I write this out, I'm going to write out S to the 25 is equal to 35,000 multiplied by 1 minus 1.03 raised to the power 25. Okay, definitely a calculator question. All divided by 1 minus 1.03. Okay, now I can do one more little simplification of all of these things, and that's to say that on the bottom here I will have negative 0.03. Okay. Otherwise, I'm going to just do this on a calculator. And I'm going to start here doing the exponent inside the bracket. Then I'm going to subtract it from 1. Then I'm going to multiply it by 35,000. And then I'm going to divide it by 1 minus 1.03 is equal to negative 0.03. Okay, that's this number here. I'm not going to write out a whole nother line. Okay, so 1.03. Better clear everything in my calculator just to make sure. 1.03 raised to the power 25 equals, well, that's pretty big, 2.09. All right, and now I'm going to say, I'm just going to make that number negative and add it to 1 is the same thing as doing 1 minus that number. So then I get negative 1.09 in, where's that number? That's the number inside this bracket, negative 1.09. Okay, so let's come back here. Negative 1.09. Move my face out of the way. This number multiplied by 35,000 equals, okay, so that's the number on the top. And then and that's not anywhere near 1.5 million, Mr. Jennings. Well, let's see what happens when I divide by 0.03, negative 0.03, okay, equals. Oh, my estimate was really good. I'm actually quite proud of my estimate. Okay, so I guessed 1.5 million, and he will actually earn 1,200,076. 1,276,074.25 over his career, provided he takes no sick days, or maybe his sick days are paid, in which case this will be his exact earnings for 25 years. Okay, everybody. So that's how you use the. Oh, don't worry about that. That's someone else's assignment. Okay, so that is how you use the mathematics of geometric series and arithmetic series. So with that, I wish you best wishes with all of your math practice today. Any questions, come find me here.